Hello everyone, welcome all. Today I am here to discuss about the topic called Introduction to Operating System and System Structure. Introduction to Operating System and System Structure. An operating system is a software that manages computer hardware and software resources. It provides a platform for running applications and acts as an intermediary between the user and the computer hardware. The system structure of an OS includes different components that work together to ensure proper functioning. Purpose of an operating system. The main purpose of an operating system is to provide an interface for user interaction and software execution. It manages hardware resources such as CPU, memory, and disk storage. It provides services like file management, process management, and device management. Types of operating system. Single user, single tasking OS like MS-DOS allows only one user and one task to run at a time. Single user multitasking OS like Windows allows multiple tasks to run concurrently. Multi-user OS like Linux allows multiple users to access the system simultaneously. System structure overview. The system structure of an operating system consists of several layers or components. The hardware layer includes the physical components of the computer, such as CPU, memory, and peripherals. The kernel is the core component of the OS that interacts with the hardware and provides essential services. Kernel functions. Memory management allocates and manages the system memory resources. Process management schedules and controls the execution of processes. Device management handles communication between hardware device and software. User interface. So let's see what are all the user interface we have. CLI, command line interface. Users interact with the OS by typing commands. GUI, graphical user interface. Users interact with the OS through graphical elements like icons and windows. Web-based UI. Users access the OS through a web browser. File management. OS manages files and directories, allowing users to create, modify, and delete them. It provides file organization, access control, and file system maintenance. File systems can be hierarchical, like folders and files, or flat, no folders, only files. Process management. OS manages processes which are instances of executing programs. It allocates CPU time, manages process synchronization, and handles process communication. Process scheduling algorithms determine the order in which processes are executed. Memory management. OS manages the computer memory, allocating and deallocating memory resources. It ensures processors have enough memory space to execute and prevent memory conflicts. Memory management techniques include tagging, segmentation, and virtual memory. Device management. OS interacts with hardware devices like printers, disks, and network interfaces. It provides device drivers, which are software components that enable communication with specific devices. Device management involves device allocation, input output control, and device error handling. System calls. System calls are functions provided by the OS for application programs to interact with the kernel. They allow programs to request services from the OS, such as file operations or process creation. Examples of system calls include open, read, write, and fork. Security and protection. OS enforces security measures to protect the system and user data from unauthorized access. It provides user authentication mechanisms, access control, and encryption. OS also protects processes from interfering with each other's memory and resources. Booting process. Booting is the process of starting up an operating system on a computer. It involves the power on self test like POST, loading the bootloader and initializing the OS. The bootloader loads the OS into memory and transfers control to the kernel. Interactions with hardware. OS interacts with hardware through device drivers, which are software modules that enable communication. It communicates with the CPU to execute instructions and manage processes. OS interacts with memory controllers to allocate the and manage memory resources. System structure diagram. So, the system structure of an operating system can be visualized using this diagram. It shows the relationship between different components and how they interact. The diagram represents the flow of information and control within the OS. System structure benefits. A well-designed system structure allows for modular and efficient development. It enables easy maintenance and upgrades of different components. The separation of concerns improves reliability, security, and performance. Common operating systems. Let's see what are the common operating systems we have. Microsoft Windows, a widely used OS for personal computers. Mac OS, the operating system used on Apple computers. We can see this software in Apple devices. Linux, a free and open source operating system used on servers and personal computers. Future trends. Let's see what are the future trends in operating systems. Virtualization, running multiple virtual machines on a single physical machine. Cloud computing, accessing software and hardware resources over the internet. Internet of Things, IoT, interconnecting physical devices and enabling communication between them. Conclusion. Let's see the conclusion. Operating systems are essential for managing computer resources and providing a platform for software execution. The system structure of an OS consists of components like the kernel, user interface, file management, process management, and more. Understanding the basics of operating system is a crucial for efficient computing and software development. Thank you for watching this video.